Now we're gonna deal with complex numbers in general. That means we're gonna let z and z prime be two complex numbers and compute the square. So what we do is we do the same thing as using the definition of the exponent, and we use the distributive law for complex numbers. So what we have is z times z is z squared. So here we do the distribution as usual. We get z squared plus z times z prime plus z prime times z plus z prime squared. Okay? So what we have is z squared, z times z prime plus z prime times z. And since c is commutative, we have 2z prime plus z prime square. We're gonna prove why z is commutative. Okay, we need to prove we're gonna prove why z prime is equal to z prime z. So this is okay. We didn't prove this one. So the key is to prove this result is to take z as a plus ib and z prime as a prime plus ib prime. Let's do it. Okay, let's do z prime times c. Okay, and we have to prove that it's the same thing as z times z prime. Okay, so let's do this one. Since the operation is distributive in R in C, so we get a prime plus a b prime plus b a prime minus b prime. Okay, so what we get a prime minus b prime, but since we know I as a factor, we're gonna put a b prime plus b a prime. Okay, so when we do the other operation, okay, when we do z times z prime, we're just gonna switch this one and we will get the same thing. Okay, we will get the same result. Nothing is gonna change. That means we're gonna get z times z prime. So we will get the same thing. So we will get, to do it fully, you will get, if you want to be careful, you will get a prime, and it's a prime a because we are in the set, because a and b and a prime b prime in this case are real, and we know that R is commutative, so we can do a prime b. Okay, or maybe let's do it here. So let's do this one here. So we get a prime a minus b prime b plus I b prime a plus a prime b. Okay, and the I prime a is the same as a prime. B prime b is the same as b prime because R is commutative, and therefore we have z prime. That means C is commutative. Okay. The other thing that we want to compute is the difference. So let's say z minus z prime square. We do the same thing. We put z minus z prime times z minus z prime, and we do the operation as usual. Okay. So what we get is z times z is z squared minus z prime minus z prime z minus plus, in this case, z prime squared. So we get z squared, but we said that z prime is the same as z prime z, so we get 2z prime plus z prime squared. Okay, so that means z minus z prime squared is z squared minus 2z prime plus z prime squared. Okay, there is one more thing left, is that we want to compute z minus z prime times z plus z prime. So this is the result that we're going to compute. We do the same thing. We get z squared plus z prime minus z prime z minus z prime squared. And since c is commutative, this number is the same as this. Okay? That's why we get z squared minus z prime squared. We proved this one. This z prime is the same as z prime z. Okay? We just proved that. So in this case, we see that we have the same operations in R. Remember, when we have x plus y reals, we have x squared plus 2xy plus y squared. The same thing happens here when we have complex numbers. Okay? So this is rating complex numbers as z in C. Okay? But when you rate it in what we call the algebraic form, that means when we write z as a plus ib, we have to be careful when doing the operation with the I. Okay? So that's the time when we have to be careful. But for now, we just proved this result here. So this is a training for complex numbers. So you go ahead and do it by yourself. And if you see any mistakes, please correct me or text me or write it in the comment section. Thank you.